everybody. Welcome back to what might very well be my last episode hosting this podcast, Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
The podcast is not going anywhere. Don't you worry. We'll have our regular host, Andrew Dunkley, returning maybe next week, or I might be back. So this could be a very dramatic goodbye, and then I show up again. But we don't know. What we do know is that the beloved Fred Watson is still here with us today. Fred, how are you doing?
Oh, pretty good. Thank you, Heidi. Feeling for you because you've done such a fabulous job over the last 13 weeks, I think it is. Wow. We've had some hitches and glitches and all kinds of things like that, but you've come through it all wonderfully. And I think the podcast is in better shape now than it was before.
Oh, thank you. That's very kind. It's so crazy to think of, just 13 weeks ago. You guys can think about where you were 13 weeks ago and how much has changed over the summer. And for me, I was involved in a NASA proposal project where we wrote a whole proposal trying to get funding. We didn't get the funding, but it was a really fun project. I wrote another proposal that's going to be submitted to the IRB soon. It's just like, wow, so much has happened and changed in 13 weeks. What about you, Fred? How's your, winter?
Yeah, it's been a winter. Yeah, it's been a very busy time, actually. We did a tour at one point and we've done a lot of things, good things and mostly good things, one or two things that were less good, but all things are going well and we're still going strong and the podcast will continue to do so. And of course, in that 13 weeks, we had that lovely news that we were 7th in the top 50 podcasts on astronomy and space science. So that's...
Well, I have one word for that. Can you guess my word?
Mine will be awesome.
I'm going to say, wow.
Oh, good. Well, what a lovely segue into...
And that is a segue. You guys know me and love me for my segues. Wow is actually our first article of the day where we are talking about a radio signal. This is something I know nothing about. Fred knows everything about. So let's hear this from Fred.
Oh, yeah. I'm glad to hear that you were coming fresh to this story because it's one that keeps on returning and is, one of the ones that intrigues us all in the quest for whether there is intelligent life beyond our planet. So the story is, it goes back to 1977 when a telescope in your country, Heidi, a radio telescope, the Big Ear Observatory, Delaware, Ohio, that telescope had, by 1977, it had completed a really excellent radio wavelength survey of the sky, the northern sky. And it was being sort of handed over to the SETI project, Search for Extraterrestrial Intelligence. And that made it the biggest ear, if I can put it that way, because it is called the Big Ear. It was effectively the biggest ear in the world, listening for radio signals that might have had an intelligent origin somewhere deep in space. So the job it was doing was actually looking for extraterrestrial intelligence signals. The telescope's no longer there. Actually, I believe the site is now a golf course. So
oh, wow.
It's
wow.
There you go. Wow. So what happened? Well, back in 1977, your information came out on what's called a line printer feed. Basically, a printer with a lot of numbers on it. It was nothing like the elegant hardware that we've got these days, where we just immediately plot graphs and things of that sort on our lovely color screens. Everything was in black and white, and your information came out, as I said, on a printer. And so an astronomer, sadly, I can't remember his name, Jerry, I think was his first name. He was looking through this output, as I think he probably did every day, and came upon a set of numbers and letters, actually, because it's in, the numbers aren't enough for this. It's in, I don't think it's hexadecimal, but it's some code a bit like that. So you get numbers and letters. And he came across this string of letters that indicated a very, very strong signal for a very short time. And with his red biro pen, he wrote "Wow" in the margin of the printout. And that's why it's called the Wow signal. And it's been called that ever since. Sadly, what it hasn't had ever since is any real understanding of what caused it, because it was never repeated. And a lot of analysis was done as to whether it was a signal that had come from some terrestrial source, a TV station or something of that sort, or satellites, because there were, of course, satellites there. We'd had satellites in place for 20 years by then. And people have looked at things like, well, could it have been reflection of a radio signal from the moon? Because radio telescopes can pick up reflections from the moon. But no, it wasn't. The moon was on the other side of the Earth at the time, so that wasn't going to be what it was. And so it's been a focus of interest. Was it really a burst of radiation at the particular frequency, which we have always kind of thought maybe any intelligent aliens out there might use? It's a frequency that actually cold hydrogen radiates on. So it's perhaps the best known frequency in the whole of radio astronomy, because cold hydrogen radiates signals at that frequency, and that's cold hydrogen lets you map the distribution of hydrogen in space and gives us insights into the universe that we wouldn't have had otherwise. It's at a frequency of 1420 megahertz. We often talk about the 21 centimeter line because that's the wavelength of this radiation. So that frequency was what was chosen, and for the SETI search, and getting this massive signal at that frequency, of course, is very, very intriguing, and remains so to this day. So why is it in the news again? Well, because things have moved on a little bit in terms of computation and data analysis since 1977.
It sure have.
It sure has, that's right. So quite a large group of interested scientists have got together and basically reanalyzed the data. They've actually put the original printouts through optical character recognition software, so that they can actually digitize what was just numbers on a piece of paper, and that, of course, lets you then do a much more sophisticated analysis. And so what they've done is looked again at the signal, and it turns out that things are slightly different from what we thought they were, and in particular, the intensity of the signal is it's probably about 20% higher than what was originally estimated. So it was even stronger than people thought at the time, and it's got a few other little things that have changed. But at the end of the day, it doesn't really give us any more information about what caused this. And just to kind of recap a little bit, I remember writing a little article, it's probably a couple of years ago now, about the Wow signal, but about new research that had speculated on what might have caused it. And I think that is still the most likely cause. And it comes about because of a phenomenon that we didn't know about in 1977, but we do now, and that is these flares on highly magnetized neutron stars. So neutron stars are as we know, we often talk about them. They're the size of a city, but with the mass of a star in them. So they're highly compressed material. They've got intense magnetic fields. Some of them beam out radiation like a lighthouse, and we call them pulsars because we see that lighthouse beam pulsating. But these events that we call fast radio bursts, which have been known about for the last 10, 15 years or so, we think come from flares on really highly magnetized neutron stars, some the objects that we call magnetars. So these flares, they don't come out at the frequency that I'm talking about, though. What's interesting is that the suggestion is that what you've got is a cloud of hydrogen, and behind it, perhaps a long, long way behind it, is one of these magnetars, perhaps in an even more distant galaxy, that suddenly flares and beams out radio waves, which we would see as a fast radio burst. But the effect of that on the cloud of hydrogen that's between us and the magnetar is to excite it and turn it into a kind of laser. It basically excites the radio radiation within the cloud of hydrogen, and then you get that hydrogen signal. And so that's
so they work kind of like light waves going through like a prism or rain, creating a rainbow. Does it work kind of like that? Refracting the signal?
And that's part of the story. I think maybe a better way to think of it might be like if you've got something like we used to talk about organ pipes, because that's how sound waves work. If you've got a cavity and you yell into it and it's the right size, that will set up a resonance with your voice, and it will amplify your voice. And that's more or less the process that's taking place within these clouds of hydrogen. But it's on a much more gigantic scale. And so you get this almost laser-like effect on the radiation that magnifies it. And that's perhaps the best explanation so far. We have seen similar phenomena to this, but they're not as intense as the Wow signal. The Wow signal is still the most intense unexplained signal. So make of that what you will, Heidi. Is it from aliens beaming radiation somewhere? Is it from a natural alignment of two objects that give rise to this kind of laser-like radiation beam? I don't know. But I think the Wow signal will continue to intrigue astronomers and space scientists for a long time to come.
Absolutely. Absolutely. It is, it's tough because, and folks at SETI, there's probably so much confirmation bias they have to overcome, because if you're a hammer, everything's a nail. And so many times we want to look at something and go, that's gotta be what I want it to be. And then we get more pieces of the puzzle and we're like, oh, shoot, that's definitely what I was hoping it was.
Let's take a moment to talk about our sponsor, Insta360, the trailblazers in 360 and action cameras, pushing the boundaries of what's possible for creators everywhere. Last week, Insta360 dropped their latest game changer, the Go Ultra, a pocket-sized camera that's redefining how you capture life's adventures. Imagine a camera no bigger than an Oreo, weighing just 53 grams, yet packed with the power to shoot buttery smooth 4K video at 60 frames per second. It's small enough to slip into your pocket, but delivers professional-grade footage that'll make your vlogs, travel diaries, or family moments look absolutely stunning. The standalone camera is IPX8 waterproof up to 33 feet, so whether you're surfing, swimming, or caught in the rain, it's ready to roll. The Go Ultra's upgraded sensor and AI chip ensure your shots are crisp and vibrant, day or night. Low-light scenes? No problem. The Pure Video mode uses AI to reduce noise and boost dynamic range, so your nighttime adventures shine. Plus, with flow state stabilization and 360 horizon lock, your footage stays silky smooth and perfectly level, no matter how wild the action gets. Here's the best part. For the first 30 Space Nuts listeners who purchase the Insta360 Go Ultra at store.insta360.com, you'll score a free sticky tabs accessory to mount your camera on anything from backpacks to winter jackets. Just use the promo code SPACENUTS at checkout. That's store.insta360.com, promo code SpaceNuts. Check the description for links and more details. Don't miss out on this tiny titan of a camera that's ready to capture your world like never before. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
But with our next story, we are getting more pieces of the puzzle that are very clear. And this is actually about my favorite planet, Uranus. I think it is beautiful. I think it is underrated. And we are now discovering some new moons orbiting around this fantastic sideways blue marble planet.
Yeah, I mean, I always think a discovery of something like a new moon is really big news, even if it's only 10 kilometers or 6 miles across, as this one is. I do remember when I was a youngster getting interested in astronomy. We thought Saturn had 9 moons. And I don't know whether you're familiar with the total that we know now, but remember,
I'm not sure with what it's at from the last time I heard it, but it keeps growing.
it does. It's 274, Heidi.
74. I think the last time I heard it was in the 250s. So yeah,
that's right.
definitely continuing to grow.
So it keeps, and a lot of that is these are really small objects that lurk in the rings of Saturn. And of course, Uranus has rings as well. And what we found, and this new discovery, is a moon that is just on the edge of the ring system of Uranus. What I think impresses me about this story most is the achievement that it represents. And it's once again highlighting just how effective and efficient the James Webb Telescope is, because that telescope has been used to discover this moon. The moon, as I've already said, is thought to be about 10 kilometers across, 6 miles or so, something like that, maybe 7 miles. It is at a distance of 30 times the distance from the Earth to the Sun, which is, it's something like if I remember rightly, it's about 3 billion kilometers. And now,
if you were on the surface of Uranus, you'd not be able to see it. It'd be too small and too far away.
Probably, that's right. I mean, Uranus is a gas giant, so you'd be floating, I guess, or something like that. But yes,
kind of a station.
Yeah, it would almost certainly be. It would be too small to see with the unaided eye. But yes, the triumph is being able to see it from the distance that we are here on our planet. This extraordinary discovery of a tiny object at such an amazing distance away. So it's a good story. What does it mean? It means we've got a new object which currently has the name of S2025U1, which tells you that it's the first Uranus moon discovered in 2025. The S meaning satellite, so that's an International Astronomical Union code, which is commonly used for new discoveries. But it will end up with a name that is either comes from the writings of Shakespeare or from Pope, Alexander Pope, because they're the two authors whose characters are actually the names of the characters have been adopted for the moons of Uranus, with the most famous ones like Titania, Oberon, and Ophelia. These are all big name moons of that planet. Who knows what
Cupid?
Yeah, all of those. Who knows what S2025 U1 will wind up with? But it'll be something. It'll be something pretty cool, I think.
So to be a moon, does it have to be a certain size?
That's a great question. And where that blurring occurs is in the rings of objects like Saturn and Uranus. So those rings are made of many particles, some of which are just pieces of dust, but some are quite large. You've probably got things 10 meters across, which are orbiting and forming the ring systems. Are they moons? That's the question. What's the boundary between a large ring particle and a moon? And so the size is probably a critical thing. I don't think there is a size limit. I think it's more about, for example, with this newly discovered moon, yes, it's perhaps 10 kilometers across, but it's not in the ring system of Uranus. It's clearly not a ring particle. It is an independent moon. So I guess that's actually what qualifies it for the title.
Excellent. I don't know why I thought of the classic Star Wars line, "That's no moon. It's a space station."
That's right.
I'm a nerd. I can't help it.
Roger, you're loud and clear here also.
Space nuts.
I have an Amazon Alexa that I use to get my morning news, and all over the news today, while we're recording this, was all the news of the Starship launch and the success. And we were talking about that on our last episode. We had our fingers crossed. We were hopeful for the success of the SpaceX Starship launch, and it looks like it did great. Do you want to tell us more about this?
Yeah, it is. It's a really basically a good news story in the sense that once again the technology has worked. So just a recap of what we're talking about. SpaceX, their biggest rocket is the Starship, which is in two parts: the super heavy launch vehicle and what is called Ship, which is the top stage of the vehicle. And that pairing has had 10 test launches so far. Some of them were less than successful. Some of them resulted in what SpaceX terms a rapid unscheduled disassembly. We would call it an explosion, but they call it a rapid unscheduled disassembly. So it's great to report that the 10th flight, everything went absolutely according to plan. And the plans were a little bit different from some of the earlier missions. You probably remember, Heidi, that the way that the booster itself, the super heavy part of the spacecraft, returns to Earth, it returns to its launch pad and is captured by what are being called the chopsticks, a pair of arms that grab hold of it as it comes down and basically puts it back on the launch pad so it can be reused almost immediately, which is extraordinary technology. That has been successfully tested in some of the earlier missions. That wasn't the plan for this mission. The Super Heavy booster was purposely dropped into the ocean. But the ship itself made a soft landing. Now, it was a soft landing on water, and that was intended as well. And in fact, it virtually hit its target because there was a buoy with cameras on it ready in the vicinity to watch this thing land, and indeed it did. And its braking rocket slowed it down so that it basically just kissed the water and then sank down into the water. There's a lot of steam about, as you'd expect from rocket jets playing on the water surface, and that was intended as well. That was in the Indian Ocean, so I think it was something like a 45-minute flight that the ship itself made. So that was all exactly what was planned, and that's great news because it means that things are on track. It's critical that we should have a working system because, as you know, the ship itself is going to be the vehicle that will land Artemis astronauts on the moon, hopefully in 2027. Maybe it will slip a little bit, but Ship is going to be, Starship itself, the ship part of it, is going to be the landing vehicle that will take Artemis astronauts down to the surface. So it's got to work, and it's got to work well, and that's why it's great to see these tests coming good. Of course, Elon's whole motivation for building this gigantic rocket, 400 feet tall, 123 meters, his motivation is to take people to Mars. And I think that's a little bit further down the track. He might have the vehicle to do it, but I think there are a lot of problems to solve before we send people to Mars on Starship.
I've heard him say that he wants to be the first person to be born on Earth and die on Mars.
Yes.
And
Maybe you will.
there's kind of the joke. It's like, well, you need to specify if it's going to be in the landing or if you've walked on Mars. So
Yeah,
that
that's
would be
true.
a very important specification.
Yeah,
But
that's absolutely right.
either way, we are making crazy progress rapidly towards these visions. I mean, is there been a point in your career, your space career, where you saw advances happening this rapidly at any point?
No, and I mean, but there was a critical moment, which was back in 2015, and that's when SpaceX managed to successfully land a booster and reuse it, because that's the game changer. That technology that allows you to bring a booster back rather than just dumping it into the ocean, which is what happened for all the decades before that. Costing millions of dollars, but if you can reuse the booster, then suddenly you've made an economy that is a game changer, and that's actually what's happened. So yes, I've never seen things happening as rapidly as they are now.
Yeah. Has this impacted astronomy? Are we able to get more satellites and tools out there for you?
Because yes, that's right. Because it's now cheaper to launch things into orbit, then telescopes can be launched on a much lower budget, astronomical telescopes into orbit than they were before. It's so the cost. It used to be this cost that people used to talk about to get something to orbit was about $20,000 per kilogram, and that's come down to $2,000 per kilogram. And that's just a game changer. In fact, with Starship, it's forecast that it might come down to $200 a kilogram, which is just unheard of. So if you've got a cheap way of getting stuff into space, then it costs you less to have an astronomy mission. So yes, it will impact our science.
Well, that's amazing. And for all you space nuts listening, maybe we'll all one day be able to afford a ticket to space.
Yeah.
But until then, I know of something that you can do that will impact space in a positive way that's absolutely free. And I'm specifically talking to you people living in Australia. If you're a resident, if you're a citizen, this is something that you can and should get involved with that can absolutely positively impact space. So I'm going to let Fred tell you guys all about the Australian Dark Sky Alliance. I'm not saying that word right.
No, it's quite all right. It's actually Australasian, and
Australasian.
So it includes Australasia, includes New Zealand and some of the other neighbouring countries around Australia, and it's the Australasian Dark Sky Alliance, an advocacy body that was founded back in 2019, actually by my partner Marnie and other colleagues of hers came together to set up this advocacy body to basically tell people about dark skies and what you can do with them. The fact that you can see the stars for a start from a dark sky park, but since then it's basically changed quite a lot, because we've now recognised just how damaging light pollution is, not just for astronomers and stargazers and perhaps people who watch the sky for cultural reasons. It's wildlife is severely impacted by light pollution, and human health is as well. We know much more about the way our circadian rhythms require us to have this night and day succession. So the Australasian Dark Sky Alliance is always calling for good lighting. It's got an approval program for light fittings, a little bit like what is now called Dark Sky International, used to be the International Dark Sky Association, Dark Sky International, based in the USA. But here in Australia, the Alliance is currently wanting to follow a number of countries in Europe, such as France, Germany, Croatia, and in fact the European Union as a whole is looking at this, to have legislation at a national level that protects dark skies, that effectively controls light pollution, because at the moment there are no national controls here in Australia for light pollution. So they've set up a petition to send to Parliament. It's open until the 19th of September. They need 10,000 signatures for it to go ahead. You can only sign if you are resident in Australia or a citizen of Australia. So I'm sorry for people beyond our borders, but I hope you will applaud us for doing this. So anybody within Australia who's interested, if you go to the website, which is australasiandarkskyalliance.org, it's all one word, australasiandarkskyalliance.org, and you'll find the petition there, and you can sign it if you're in Australia.
Yeah. And we'll make sure we have Hugh, our producer, put it in the description so you can easily click on it too. And I know we try not to get political, but this is an important cause. And, with being the, what are we, seventh most listened to astronomy podcast in the world, we're hoping this platform can help us get to the signatures. And if you're not in Australia and you feel compelled to help, just share it on your social media platforms, and then maybe your reach can help us expand this mission and just help us keep our skies dark and the stars shining and the vision of space and the space nuts being able to look up at the stars with our naked eye for the future.
Sounds great. You're a good advocate for dark skies, Heidi. Thank you for those words.
Well, that's why I'm a space nut. It's I think every single one of us who's in this industry, you grow up and maybe you're with a beloved relative or a friend and you're looking up at the sky, and then your first camping trip where you really get out there and you're looking up and you see the Milky Way for the first time. It's burned in everyone's memory. I mean, all of you listening to this, you guys know how awe-inspiring that feeling is, and we really do want to protect that. I think it's something that it's almost part of being a human. Because there's no other animal that looks up and admires the sky like we do. I mean, we really are meant for the stars, I think.
Came from the stars and meant for the stars, absolutely.
And that's it for me being an absolute cheeseball. You guys, we'll see if we get Andrew back next week, because we'll go from just me being a cheeseball to Andrew with his dad jokes. But if you guys don't have me back on next week, I've really enjoyed being your host for this summer. I always joke it's summer for me. I'm in Houston, Texas, Space City, and Fred's in Australia, so it's winter for him. It's nighttime for me right now and daytime for you, so it's a fun little global adventure. So I just want to say thank you to all of our listeners for having me on. And Fred, it has been a pleasure. And I will see you again very soon for our Q&A episode.
Can't wait, Heidi.
Hello, Hugh. Thought I'd say your name first today. Heidi, Fred, it's Andrew here reporting from New York City, just near Times Square. Since I spoke to you last, we visited Halifax in Canada. And we did a trip out to Peggy's Cove, which is a lovely little village out on the granite outcrop there with probably one of the most famous lighthouses in the world, which was just adorable. And then we had a look around Halifax itself before getting back on board and travelling to New York City. We got off and have spent the last 2 days in New York looking around. We went to the 9/11 Memorial. We wanted to do that in 2012, but we couldn't get in because the security was too tight and we didn't have our passports. But this time we did, and wow, yeah, very sobering, I think would be the best way to describe it. And the museum is incredible, built on the foundations of the old Twin Towers. You can still actually see the footings and the slurry wall that keeps the Hudson River out, which didn't actually fail when that building collapsed. Very, very sobering is all I can say. We felt very sad most of the time walking through there. I think the most telling moment was when the you went through a part of the museum and they played 911 calls and messages that people were sending to their loved ones, and yeah, that just hit you in the face. And then we did a walking tour and we did everything. We went out to Liberty, Ellis Island. We went over the Brooklyn Bridge. We walked across it. We went to Chelsea Market. We went to the Rockefeller Centre, and we finished the day off with a trip out to Yankee Stadium and watched the baseball, where the Boston Red Sox beat the Yankees 6-3. So there was a hell of a lot of booing. And I got to tell you this, on the train coming back, there was a street performer who wanted to do a backflip, and no one was interested. We were all too tired. Anyway, he did his backflip, and then he abused us because no one would tip him. Oh, it was funny. So funny. Oh, and they were giving away bobblehead dolls at the baseball because it was Seinfeld night. And they were George Costanza bobbleheads. And we were handed these as we walked in. We didn't know what to do with them. So we're walking along and people came up and offered us money. We walked away with $80. So I love New York. It's such a weird and wonderful place. Anyway, that's where we are. Today we're heading off for Washington, D.C., and then up to Niagara Falls, and then to Boston. But I'll be home by the time the next report's due, so this would probably be my last. And once we get settled in our new home and we get the internet on, I might make a comeback on the show, unless Heidi's done such a great job they're going to kick me to the curb. Either way, we'll see you real soon. That's it from me. Hope you've enjoyed my holiday as much as I have. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.